Okay, today's chapter is kinematics. Kinematics is study of motion. Motion, again, is some kind of thing that seems very easy when somebody says moving, but is not as easy as it seems when we start explaining it to somebody. Let's see. Who can tell me how can we differentiate something which is moving from something which is not moving? Now, motion, to understand motion, we need to understand frame of reference, and we need to know that motion is not a quantity that can exist uh, uniformly throughout the universe at every point. The concept of motion changes when we change the reference of the study of the space in which the object is moving. For example, if we are sitting in a car and the car is going at a speed of say 80 km per hour, we see that the whole car is moving. I am standing outside and there are four people sitting in a car and they've just passed by me. And I feel that the whole car, the people sitting inside and all the interior of the car, they were all moving according to me. But do you think the interior of the car and those four people who I saw sitting inside the car, they were moving according to one another? Nope, they are not moving. I hope you have traveled in a car with somebody in it. You would notice that you don't feel like the other person who is beside you is also moving at the same speed as you are moving. Why is that? We feel the car is moving, but we don't feel the things inside are moving because they are moving with us. The whole reference is moving with us, so we don't feel the motion. Motion is a quantity that always explained with reference to the frame of reference, or in simple words, surrounding. Believe me, if you imagine dark black space around you, and you are an astronaut in deep, deep space, and there is nothing, not even the spaceship or any planet or any moon or solar system, there is nothing near you. The first problem you will have, you will never know whether you are moving or not. There is actually literally no way to know. Either you are moving or not, or if you're moving in what direction then. So the motion movement is a quantity that needs a reference. So motion means, for simple words, it will not be true for some uh, high-end physics, but for beginners, we say that an object is said to be in motion if it changes its distance and or position with respect to surroundings of the object. So you don't feel the car is moving. You don't feel right now, if you're not attending this lecture in a class, not attending this lecture in a car or a train or a plane, You're sitting in your room, you might not feel that you are moving. But believe me, you are right now moving with a speed approximately 1600 kilometer per hour. This is faster than you ever flew in a plane. This is the speed of the surface of Earth when it is moving around itself. This is the speed of an object near equator when Earth is spinning around its own axis to complete a day. And we don't feel it. Did you ever bother to know why? Actually, the reason is that we are moving with it. The whole reference is moving with us, so we never know. Motion is a quantity with reference to the surrounding. So here comes the first quantity of motion, speed. As you see, the motion is change of distance with respect to time, then speed is that how much distance you change in how much time. Okay, okay. If you are changing position, it means you are moving. But if you change that position in less time, it means you are moving fast. And if you change the same distance in more time, it means you're moving slow. So comparing the change of distance with time produces another quantity which is known as speed. So speed is change in distance divided by time taken to produce that change. Symbolically, V equals to S over T. Remember, this formula is not good for calculating all kinds of speeds. This is good to define speed, but we cannot use it to calculate all kinds of speeds. S is distance or displacement. T is time, or we can call it duration, or sometimes it is called time taken, same thing. V is speed or velocity. The units are very important as well. Distance should be in meters, time should be in seconds, then speed will be in meters per second. And if distance is in kilometers, speed is in hours, then, sorry, time is in hours, then speed is in kilometer per hour. Remember, 1 meter per second equals to 3.6 kilometers per hour. So if you are traveling at a speed that you travel 1 meter in 1 second, you will travel 3.6 kilometers in 1 hour. So you need to remember this conversion. It can save you time, and you do not have to convert meters separately to kilometers and seconds separately to hours and then divide. You can just use this relationship to find or convert meters per second to kilometers per hour directly. This is conversion relation. So Speed can have some forms: constant or uniform speed, variable speed, instantaneous speed. Now, what are these speeds? What is constant speed? Just 1 second. So, how will we explain an object is moving constant speed or not? Like, how can we explain it, or how can we actually know it? So there is one liner for this thing. An object is traveling with constant speed if it moves equal distances in equal intervals of time, no matter how small the intervals are. For example, if an object travels 10 meters in 1 second and another 10 meters in the second and another 10 meters in the next second, it means it is moving with constant speed because it is traveling equal distances in equal intervals of time. Variable speed, an object is moving with variable speed if it travels unequal distances in equal intervals of time. If an object is traveling unequal distances in equal intervals of time, it is variable speed. What is meant by instantaneous speed? Instantaneous speed is speed at a particular instant. Some very common examples are initial speed and final speed. Initial speed means speed at the beginning of observational period, and final speed is speed at the end of observational period. Some student just think that by initial always means in the beginning of the journey and final means at the end of the journey. If that would be the case, then initial and final should always be zero. But that is not the case. What actually is that we observe a constantly moving object and we observe it for a small piece, like from instant one to instant two. The speed at instant one will be the initial speed, and in speed at instant two can be the final speed. But this final speed, in case if it is when the object stops, is zero. And the initial speed is the speed when object starts moving, then it is zero as well. So initial speed and final speed may or may not be zero. So you cannot consider they are the speeds at the start and the end of the journey. They are speeds at the start and end of the observational period or observational time. Sometimes we have a constantly moving object and we split it into observational period number one, observational period number two, and observational period number three. In that case, the final speed of observation period number one can be the initial speed of observation period number two. So these kind of questions can appear in front of you as well. Although in AS syllabus, examiner does not give you those kind of questions because they, in that case, examiner has to give you so many marks for some very easy questions. So examiner does not like that. Examiner just wants to know by throwing a kinematics question, he wants to know certain things. Do you understand them or don't you understand them? Because he has to judge you on the basis of that. So he never gives you a very long question like that to judge the same thing over and over again. So let's see what is next. Hmm. An object is moving, actually, not one object is moving. Let's say if there are multiple objects moving. Okay, this is a top view of a car. Okay, done. And I have three of them. So C, V, no. Oops, I did not make the windscreens. They're not important, but just to. Okay, these are three cars. This is car number car one. This is car number two. This is car number three. Okay. Now they are all moving on a straight road, side by side. This is a pole, and on the top of a pole, there is a person standing who is observing the motion of these vehicles. This is a person. Okay. So this person is looking down on the vehicle. So he observes these vehicles moving and records their motion. Yeah. Okay. Let's make a table of the three cars. So this is car number one, distance in meters. Car two, distance in meters. Car three, distance in meters. And this is time in second. 0, 1, 1, 2, 3, 4, and 5. Car number one, 10, 20, 28, 34, 38, and 40. Car number two, 10, 12, 16, 22, 30, 40. These are distances in meters that are measured for car number one, car number two, and car number three from the person who is observing them. So car number three has traveled 10, 16, 22, 28, 34, and 40 meter of distance. Now, just observing by this situation, can you tell me which car is moving with constant speed and which car is moving with same speed and which car is moving with uh, constant speed, increasing speed, decreasing speed, and constant speed? Okay, I'm pausing the recording so I can talk to you.